All right, guys. So in this next section, section 2.2, we're going to look at compound interest. So as a reminder, we're going to look at simple interest to begin with. You guys should have seen this a little bit in section 2.1, and then compare that to compound interest. So our different formulas are here. So simple interest, compound interest, and continuous interest. Okay. So simple interest is just when the interest is based on the original principal. Compound interest will be when interest is compounded or calculated a specific number of times a year. So, for example, if your problem says something like interest is compounded semi-annually or compounded quarterly, that's when you would use the compound interest formula. And then the continuous interest formula would be if your problem states that interest is compounded continuously. Okay, so let's go ahead and let's take a look at some of these examples down here. Okay, so we're going to start off with just some simple interest as a refresher. All right, so our first problem says a person has a Visa balance of $5,200, which is being assessed at 18% APR finance charge. If this is calculated using simple interest, what is the interest for 1 year? Okay, so simple interest is the I equals PRT, right? Where P is our principal, which would be the $5,200. R is the interest rate, which would be 0.18. Always change your percent to a decimal. And T is the time in years, so that would be 1 year. So in this case, our I would equal 5,200 times 0.18 times 1. Okay, so if you punch that into your calculators, 5,200 times 0.18 times 1 would give us $936 in interest. Okay. All right, so 18% of $5,200 would be $936. Okay. All right, so then the second part of this says she's hoping to pay off her debt within 2 years. So this would require a monthly payment of $259.60. What is the total amount that she will pay? Okay, well, if she's paying $259 a month for 2 years, so this is $259.60 per month. We know that there's 12 months in a year, and she's paying this for 2 years. So multiply her monthly payment, times the number of months in a year, times the number of years that it's going to take her to pay it back. So if we multiply that out, so 259.6 times 12 times 2 would give us $6,230.40. So that's the total amount of money that she would be paying over this 2-year period if she were making these monthly payments. Okay. All right, part 3 then says the amount paid in interest is the difference between the total amount paid and the amount owed. So how much was paid in interest? Okay. All right. So the amount that she paid was the $6,230.40 that we just found. And the amount owed was the $5,200. That was the original balance on her Visa card. Okay, so if we subtract these, $6,230.40 minus $5,200, then the interest that she paid was $1,030.40. All right, so then the last question says, what percent of the amount owed is the interest paid? Okay, so what percent of the amount owed is the interest paid? So basically that's telling us amount owed goes on the bottom, interest paid goes on the top. Okay, so the interest paid we just found was $1,030.40. The amount owed was the original $5,200. So if we divide these, that's going to give me 0.198. And if we multiply that by 100 to change it to a percent, that would be 19.8%. Okay, So she paid 19.8% of the original amount owed. Okay. All right, so that's just simple interest. Okay. So now we're going to start looking at compound interest, which is going to be used in this formula right here. So when you're looking at this formula, A is the balance after T years, P is your original starting balance or your principal, R is the interest rate written as a decimal, N is the number of times that interest is compounded per year, and T is the number of years. Okay. So let's go ahead and let's take a look at some examples. So all of this up here is showing you how you can do some of this stuff using your graphing calculators. On the left-hand side, this is the older operating system. So like if you have a TI-83, this is how you would do it in the TI-83. Over here on the right-hand side, this is more of how it's going to look in the TI-84s or the TI-84 Plus. Okay, I'm going to show you how to do these by hand, but the nice thing is that you can use this information right here in order to check your answers. And you can also quickly make adjustments if you want to say, well, what if my principal was $1,000 higher? Or what if my compounding period was smaller? And you can make quick adjustments and not have to run through all of the same calculations by hand. So that's kind of a nice feature of doing the calculator. Okay. All right. So like I said, we're going to look at doing some of these by hand though, because that's the trickier part. So that's what I want to show you together as a group here. All right, so this first one says, if you invest $5,000 into an account that pays 10.5% interest per year, compounded daily, how much money will be in the account after 20 years? Okay, all right, so we're using our compound interest formula. Okay, so we need to start by finding the different pieces that are given to us in the problem. Okay, all right, so it says, you're investing $5,000. So that is going to be our principal. It's your starting value. Okay. You have an account that pays 10.5% interest per year, compounded daily. Okay, so the interest rate, our R, if we change that to a decimal, would be 0.105. Okay. Compounded daily. So I'm just going to say 365 days in a year. There are, technically more like 365.25 because of the leap year, but let's just go with 365. We'll get a close enough number. Okay. And the time we're given is 20 years. Okay. All right. So our formula is A is equal to, again, we're just using this formula right here, just plugging in the pieces that we were given. So here, A would be equal to 5,000, and then in parentheses, 1 plus 0.105 over 365, end parentheses, and then raised to the power of 365 times 20. Okay, so I just plugged in the information that we had into the formula that we were given. Okay, all right, so now I'm going to pull out my calculator and show you how to plug this in. Okay, so there are lots of different ways that you can plug this into a calculator. Okay, this is just the way that I tend to like to do these because I think it avoids as many errors as possible. So what I always do is I start with just the fraction part inside my parentheses. So I would do 0.105 divided by 365 and hit enter. Okay. Now, I tend to be a little bit lazy on these and I don't want to write down all these numbers as I go. So I use my calculator to help store these numbers along the way. Now, one cool thing is that if we were to take this, because now we want to take this number and we want to add 1 to it. If I just hit the plus sign right here, my calculator takes that answer that it just figured out and it's then just going to add whatever number I plug in to it. So if we want to add 1, I would just hit the plus button and then 1, and it's going to say I'm going to take the previous answer and I'm going to add 1 to it. And I'm going to hit enter again. Okay. All right, so after you add the 1, then you want to do the exponent, okay? Because remember your order of operations, PEMDAS, so do your parentheses and then your exponents, okay? So I'm going to do my little caret symbol here that's above the division, okay? And again, it did the answer, so it's taking my previous answer. And then I'm going to do a parenthesis and then the 365 times 20 end parenthesis and hit enter. All right, so that's given me all of this right here. And then lastly, we need to multiply by the 5,000. So again, I'm just going to hit times. It's going to take my previous answer and I'll do my 5,000. Okay, so our answer here then is 40,818 and 52 cents. Okay, so if you invest $5,000 into an account that pays 10.5% interest per year compounded daily, then after 20 years, you're going to have $40,818.52. Okay? All right, let's go ahead and take a look at another example. Something happened here. My page got off, so I'm just going to get rid of that guy. All right, so this next one says, how much money must I deposit on the day my child is born into an account paying 8% interest per year, compounded monthly, so that there is $20,000 in the account on her 21st birthday? Okay, so let's again start by looking at what information we were given. So how much money must I deposit on the day my child is born into an account paying 8% interest? So our R is 0.08, compounded monthly, so 12 months in a year, means that N is equal to 12, so that there is $20,000 in the account on her 21st birthday. Okay, so we want there to be $20,000, so that's going to be the final amount. So our A value in this case is $20,000, and we want that in there on her 21st birthday, so our T is 21 years. Okay. All right. So now we're again going to plug this information into our formula. Right? So we're using this guy right here. So our A value, $20,000, is equal to P, which is our unknown this time, and then parentheses, 1 plus 0.08 divided by 12 raised to the power of 12 times 21. Okay, so this time our goal is to solve for P. Okay, so I'm again going to start with this piece right here, and let's plug that into our calculators. All right, I'm going to again start with the fraction, so 0.08 divided by 12, hit enter. Then I'm going to do plus 1, enter, caret, parentheses, 12 times 21, end parentheses. Okay, so that's giving me this number right here. Okay, so that is 5.3357249,709. Okay, times P is equal to $20,000. So if we want to get the P by itself, then we just need to divide by that 5.3357249,709 number on both sides of this equation. So over here, again, I'm going to use my calculator to help keep track of some of these numbers for me. So I'm going to put in the $20,000 divided by, and then instead of typing in that number If you hit second and then the negative symbol down at the bottom, it again uses that previous answer and then hit enter. All right, so this has given us then our principal balance that we need to invest in this account when our child is born is $3,748 and 32 cents. Okay, so that's how much money needs to be invested when your child is born in order to have $20,000 on their 21st birthday.